Good morning, Year 11 Mathematics Extension 1 students. Today we're starting the topic of polynomials, which is a pure Extension 1 topic. And we're learning about the division of polynomials. So long division is a way to divide a two-digit number without using a calculator. We can also use this method to divide polynomials, and it allows us to factorize polynomials. So a polynomial can be written in the form of px equals ax qx plus rx. This is where px is the dividend, ax is the divisor, qx is the quotient, and rx is the remainder. So the degree of the remainder rx is always less than the degree of the divisor ax. So let's have a look at some examples. So we're going to jump straight in and divide px equals 3x to the power of 4 minus x cubed plus 7x squared minus 2x plus 3 by x minus 2. So to do this, we want to write our x minus 2 out first, and we want to write this like a long division. So we then go so we write out x minus 2. Make sure you leave a bit of space because your answer is going to go on the top here. And so we write our division sign out, or long division sign out, and then we write our polynomial underneath. So 3x to the power of 4 minus x cubed plus 7x squared minus 2x plus 3. And so what we do to start off with is we divide our first term in our polynomial by the first term in our divisor. So we go 3x to the power of 4 divided by x. So 3x to the power of 4 divided by x is just 3x cubed. So then we multiply this 3x cubed by x minus 2. So we go 3x cubed times x is 3x to the power of 4. And 3x to the power of 3 times negative 2 is negative 6x cubed. What we now do is we subtract all of this. So we go 3x to the power of 4 minus 3x to the power of 4 is 0. And then we have minus 1x cubed subtracted by negative 6x cubed, which gives us positive 5x cubed. What we then do is we bring our next term down. So we bring down our positive 7x squared, and we repeat the process. So we divide our our term with the largest degree, so our 5x cubed, by our x. So 5x cubed divided by x is plus 5x squared. And then we multiply our 5x squared by x minus 2. So 5x squared times x is 5x cubed. This term should always be the same in hoping to cancel it out. And then 5x squared times negative 2 is a negative 10x squared. So then we subtract these. So 5x cubed minus 5x cubed is just 0. 7x squared minus negative 10 x squared is positive 17x squared. We then bring our next term down of minus 2x, and we repeat the process. So we divide our x by our largest term. So 17x squared divided by x is plus 17x. And then we have to multiply the 17x by x. So 17x squared times x is 17x squared. And then 17x squared times negative 2 is negative 34x. And then we subtract. So 17x squared minus 17x squared is 0. Minus 2x minus negative 34 is 32, so plus 32x. and then we bring our plus 3 down. We divide our 32x by the x, so we have plus 32 up here, and then we multiply our x minus 2 by 32, so it's 32x, and then it's minus 2 times 32, so minus 2 times 32, which is negative 64, and we subtract, so we get 32x divided by minus 32x, sorry, is 0, and 3 minus negative 64 is plus 67. And so once you get to a whole number or 0 with no pronumerals, you have finished dividing. So now what we want to do that we've divided that is we want to write px in the form of p equals ax qx plus rx. So off to the side here, I'm just going to write what everything is. So we have that our px is our polynomial, which we already know. Okay, our ax is our divisor, so that's what we divided the whole thing by, which is x minus 2. Our qx is what we got as our answer, which equals 3x cubed plus 5x squared plus 17x plus 32. And our rx is our remainder, which is our whole number down here, which is 67. So now we want to write that in the form. So we're going to write our polynomial first. So 3x to the power of 4 minus x cubed plus 7x squared minus 2x plus 3 equals, in brackets, our ax, which is x minus 2, in brackets multiplied by our qx, which is 3x cubed plus 5x squared plus 17x plus 32. And then we add on our remainder of 67. So that's how we write px in the form of px equals ax qx plus rx. And finally, we want to show that p of 2 is equal to the remainder. So we're going to sub 2 into our polynomial. So p of 2 equals 3 times 2 to the power of 4 minus 2 cubed plus 7 times 2 all squared minus 2 times 2 plus 3, where 3 times 2 to the power of 4 is equal to 48 minus 2 cubed is 8 plus 7 times 2 squared is 28 minus 2 times 2 is 4 plus 3, and then we're going to add this all together, and when we do so we get 67. So therefore P2 is equal to the remainder. Alrighty, if you are following through the Maths in Focus textbook by Margaret Groves, you now would do exercise 601 on page 290.